All right, take two. So today we are going to be starting chapter 9, which is all about how compounds are named. And this is a section of chemistry that essentially, like, if you remember when you were a kid and you learned grammar rules, like, oh, when does the I go after E? When do you, I don't know, put these two consonants together? How does that sound? Et cetera, et cetera. It's the same concept, except for we're going to be doing it for naming chemical compounds. So there's a lot of rules that you need to learn, and there's no way to learn it except for to memorize it or to just practice. There are some things you can do to understand why it is that way, but for most of these rules, they are just the way that they are. Now, if the font's too small, let me know. I am recording this, but if it doesn't work, I will post it later. Actually, on the posting, you should definitely be able to see the font, but I don't know, Zoom's weird when I share my screen via OBS. So let's get started. So we've seen this before. This is the number of valence electrons from the periodic table. Okay, and I'm just doing this as a reminder. All right, so 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, and it goes by columns. Okay, so column 1A has 1, 2A has 2, 3A has 3, 4, 5, 6, 7, 8. Hopefully that is a reminder for you guys. Now, I want to also remind you of this version of the periodic table that we've shown, which it's based on the valence electrons, but these are the ion charges that we have of certain groups. Okay, and they pretty much are, locked in stone. So group 1A has an ion charge of +1. Group 2A has an ion charge of +2. Group 3A has +3 through aluminum. Like on your periodic table, you'll see that staircase here. So the charge will just go through the staircase. Group 5A has a charge of -3, 6A -2, 7A -1. Okay, again, you can write this on your periodic table, or you can use this version of the periodic table, but you have to have that memorized. These charges, +1, +2, +3, -3, -2, -1. Okay, again, that should be a review for you guys. So let's get to naming cations and anions. All right. So the names of the metal ions, which are cations, are it's very simple. You just take the metal name and then you add the word ion after that. So quick example, Mg2+. Okay, Mg is magnesium. So we just call it the magnesium ion. Okay, so that's all you do for the metal ions. It's very straightforward. Okay, for the non-metal ions, or the anions, it's a little bit more complicated, but again, it's still pretty straightforward. Okay, you're just going to take the non-metal and you're going to add the suffix "ide," IDE, to the non-metal name, and then, whoops, forgot to write in the last part, and then add ion at the end. Okay, so it's just going to be non-metal, change it to "ide," and then add ion at the end. So here's 3 examples for you guys. All right, F- is fluorine, so it becomes fluoride, and we just call it the fluoride ion. O2- is oxygen. All right, it's the oxygen ion, but we dropped the YGEN, change it to oxide. Okay, and then just call it the oxide ion. N3- is nitrogen. All right, so we drop the ogen and we just make it nitride ion. Okay, it is like, if you just do your best to add the "ide," I'll give you credit for it, but in general, you just kind of have to memorize, what becomes what. Like phosphorus becomes phosphide, silicon becomes silicide. Like, they all have their own kind of nuances, but as long as you're trying to add the IDE, then, I'll give you credit for that. Any questions about this so far? Okay, no
Mr. Chung,
questions. Oh
I
yeah,
have a
go ahead.
question.
Yes.
The columns in the middle don't have valence electrons.
Okay, so Aja asked a great question, and I am repeating it because I don't think your question comes out on the recording. But Aja asked, do the columns in the middle, do they have charges? They do have charges, and we're about to get to it, but they're not like set in stone. Like these ones that have been labeled here, it's always +1, always +2, always +3, -3, -2, -1. The transition metals, they all have different charges, so there's no like hard and set rules as to what charge each of these metals is going to have. And there's no way to know all of them except to memorize all of them. And so let's get to what transition metals look like right now. And you're not going to have to memorize all of them, but you are going to have to memorize some. Okay. So ion charges of transition metals. Okay, transition metals, like all those blue metals that we saw on that periodic table, okay, they form cations just like the other metals. Okay, they're going to lose electrons and they're going to become positive. Okay, they're all metals. Now, you don't need to know why, but you're going to need to memorize a few of the transition metal charges, and I'll show you why it works. I think I did it the other day, but I'll show you why it works right now. Okay, so the other tricky thing about transition metals is transition metals have oftentimes they have like multiple charges that they can form. And so it's not always like just one charge like the simple ones that we started with. So for example, iron, which is Fe, I think it's number 26 on your periodic table if you have your periodic table open. Yep, number 26. Okay, it can form either Fe2 plus or Fe3 plus. Now I'm going to show you why that works. You don't need to know this, but it might help some people to kind of understand, or at the very least, it should show you why iron forms multiple ions. Okay, so if you take a look at just iron by itself here, okay, iron's electron configuration is noble gas configuration, argon, and then 4s2 3d6. Okay, now the Fe2 plus ion is just going to drop those valence electrons, the 4s2 valence electrons, okay, and just going to make it Ar 3d6. Okay, so it's pretty straightforward for us to understand. Why would iron form a +2 charge? Simple, it just gets rid of these electrons in the fourth energy shell, and then it's going to be happy. Okay, a little more complicated is, why would iron form a 3+ charge? Okay, so when it forms a 3+ charge, it loses one more d electron, all right, and it becomes the same as argon 3d5. Now, the reason why that works is, remember what happens when we go from d5 to d6? Does anyone remember? Like in terms of filling, drawing in those arrows, what would we have to do when we go from d5 to d6? Okay, so if we are drawing the arrows, remember, so how many orbitals does 3D have total? Like how many lines do we draw that we put the arrows in? The answer is 1, 3, 5, or 7. Which is it? All right, correct. So it's 5. So there's 5 orbitals in the 3D, right? So if you think about 3d6, okay, we've put 1 electron in each of the 5, but then we've doubled up one of them. But 3d5, it's just 1 in each. And remember when we talked about the bus? Like everyone's happy when they don't have to share a seat, right? Well, electrons are the same way. So that's why iron is perfectly happy forming this 3+ charge, because in its 3D level, in the 3D bus, right, it's just 1 electron per orbital, and so they're happy. Okay, so like I said, you don't need to understand that, but if you understand that, you'll kind of get why these transition metals, because they have the Ds, they have a lot more room to play with, and then they'll form different ion charges. Okay, Again, you don't need to know why, but you need to memorize some of them. All right. So let's talk about how we name them before I talk about which ones you need to memorize. Excuse me. So transition metals are named based on their ion charge. And the charge is written in Roman numerals. Hopefully, you need to know your Roman numerals up to, I think, 6. All right. So here's some examples. Fe2 plus is named iron Roman numeral 2. Okay. And this in brackets, you don't write that. I'm just telling you how to pronounce it. It's pronounced iron 2. Okay. So if Fe2 plus is iron II or iron 2, what do you guys think Fe3 plus is going to be? That's correct. It'll be iron 3. That's how we say it out loud. But when we write it, we're going to write iron parentheses III. Okay, so that's iron 3. Okay, a couple more examples. Cu plus, all right, a +1 charge is named copper 1 with the Roman numeral 1. And Cu2 plus is named copper 2 with the Roman numeral 2. Okay, so this is just how we name them. Iron 2, iron 3, copper 1, copper 2. That's how you say them. Now, right now, you're probably not confused too much when I say the Roman numeral has to do with the charge, but now is the time to get that into your head, because when we get to forming compounds, what will happen is you will have something like Fe2O3, and then you'll want to call that iron 2, but it's not actually iron 2, it's iron 3. Okay, so we'll get to that, but if right now all you do is memorize that the Roman numeral is the same as this charge here, okay, you'll go a long way to not confusing yourself later. All right, so these are the transition ions you need to memorize. I'm not going to go all over them right now. All right, but there are 10 that you need to memorize. Copper, iron, Sn is tin, Co is cobalt. Okay, there's like, if we were in person, I would give you note cards and tell you to put them on note cards and make flashcards for yourself. Okay, you just have to memorize these. It actually gets easier than you think it would be, because when you start doing compounds, you can actually just figure out what the charge is. But barring that, you still need to memorize these these 10 ions. Okay. Now, looking at this chart, you guys should have some questions about what's going on here at the bottom with silver and zinc ion. All right. So if you
Wait,
look at
Mr. Chung,
yes.
are these the transition metals that can make more than one, that have more than one ion?
Correct. These are all transition metals. So if you look at, Aja just asked again, sorry, her voice doesn't come through the recording, but Aja just asked, are these the transition metals that form more than one ion? And yes, the answer is yes. If you look at all of these, like copper, iron, like if you find them on your periodic table, they're all in those columns, in the transition metal columns. Okay. However, you should be asking me about silver and zinc. Okay. Because if you notice, silver and zinc, even though they are transition metals, I only give you one option for the ion. That's because silver and zinc are the only two transition metals that only form one ion. Okay, silver is always +1 and zinc is always +2. All right, so if you write out the electron configuration, you might be able to figure out why that's the case. You don't need to know why, but it's the case. All right, silver is always +1 and zinc is always +2, which brings up one of the first of many annoying exceptions that you're going to need to memorize. But you would think that since silver and zinc are transition metals, you would call them silver 1 ion and zinc 2 ion. But because there are no other options, all right, you just call them silver ion and zinc ion, which is why I have them here as a transition ion that you need to memorize. Okay, notice all the other ones, they have multiple options, so we have to use the Roman numeral. But for silver and zinc, there's no other option, so you just call them silver and zinc. All right, there's going to be a ton of exceptions, just like there's, you know, honestly, like the fact that you guys had to learn English as a language that you speak should have well prepared you for naming stuff in chemistry, because English has all these asinine rules that don't make sense, and you know, all these exceptions and things like that, like, oh, E before I in neighbor and way, like, oh, why has it got to be like that? It's dumb. Okay, so chemistry is the same way. There are going to be exceptions, and all you do is memorize them. I don't have any cute rhymes like we learned in elementary school, but if you do, or if you can come up with one, I don't know, 5 gold stars. Okay, so these are the ones you need to memorize. I've already posted this PowerPoint on Google Classroom, so you don't need to write these down. You have them on the PowerPoint to use if you need. Okay, and remember, everything is always kind of open notes, so you'll have this with you. So at the very least, you need to know how to access this information. I should say, in case I use this in future years, that I'm talking to the class of 2021 when I'm saying that open notes thing. All right, the last thing we're going to do today is look at something called polyatomic ions. All right, so some ions are composed of more than one atom. These are called polyatomic ions. Poly meaning many. All right, again, these are things you're just going to have to memorize: formula, charge, and their name as well. If you you could actually, if you wanted to, draw the Lewis dot structure of all these polyatomic ions. In fact, it'll probably be a bonus question for you guys on a future exam. But if you understand how to draw Lewis dot structures properly, for a lot of these, you will be able to figure out, like, oh, I understand why this polyatomic ion is the formula that it has. All right, so that's just a little fun thing you can do on your free time, because I know you guys love to do stuff like that. Okay, so 7 polyatomic ions you need to memorize. Okay, and I'll go through all of these because they are all important. NO3 minus. Okay, that means 1 nitrogen, 3 oxygens. NO3 minus has a -1 charge. All right, it's called nitrate. Okay, if you ever see this suffix ate, ATE, it's generally a huge flashing warning sign that you're dealing with a polyatomic ion. All right, OH minus, -1 is hydroxide. Okay, so 1 O, 1 H, -1 charge. Okay, you're very familiar with hydroxide because HOH, all right, hydrogen hydroxide, is actually just water. HOH is H2O, if you think about it. There's 2 H's, 1 O. All right, CN minus, -1 charge is cyanide. Don't eat that. SO4, 2 minus, 1 S, 4 oxygens, has a charge of 2 minus. That's called sulfate. All right, CO3, 2 minus, -2 charge, it's carbonate. PO4, 3 minus, a -3 charge, is called phosphate. And then the one cation, polyatomic ion you need to memorize is NH4 plus, which has a +1 charge, and that one is called ammonium. Okay, so these are the polyatomic ions that you need to memorize. Any questions about that? Okay, so the bad news. Starting on, let's say Friday, like I said, the only way to learn this stuff is to practice, 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 practice. Okay, so this is the portion of the class where you are going to start getting daily quizzes. All right, each quiz is about 5 minutes, or generally takes people 5 minutes to finish. Okay, and you know, the point of the quiz is for you to practice, just practice naming things. It's like, I don't know, it's like a spelling quiz when you were a kid, or a vocabulary quiz. You know, it's just to practice, you know, doing and knowing these ions. Right now, you're only memorizing these ions, but the next thing we're going to do is we're going to talk about how to put them together, right? Like, so why is it called sodium chloride? Why is it called magnesium chloride? Why is it called, you know, why are things called nitrogen dioxide, right? So you're going to start learning all those rules, and all these rules are going to pile on top of each other. And the only way you're going to keep them straight in your head is to practice, 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 which is why you're going to have quizzes daily starting next Friday, or starting this Friday. All right. It's going to be daily, and it's going to run for a couple weeks. Now, the good news is, all right, they're only like 5 points each. I dropped the lowest one. But the bad news is you're just going to have to steep yourself in this stuff until you get it. All right. So practice makes perfect, which is why you have to do the quizzes. We'll do it here in class. It'll just be a Google form that you do at the beginning of class. But this is your warning now that that is how, you know, I'm going to make sure that you learn this stuff. So make sure you rewatch this when I post it. The first quiz on Friday is only going to be on ions, so it shouldn't be too complicated. And again, since at least for the class of 2021, since we're online, you know, I'm leaving things open notes, so there really should be no excuses. But you know, you're going to have to do your best to learn this stuff.